Alright, so picking up at number 26. So these problems now say to verify the identity. Okay, so with 26, it is the tangent of theta, cosecant of theta, cosine of theta is equal to 1. Now, this says to verify. I want to make something very clear. Do not touch the right side. You are making the left side look like the right side. Okay? If you've done the problem correctly, the left side will match the right side. Do not move things over. Don't be like, oh, I'm going to divide by tangent. Don't do that. Automatically wrong if you do that. Okay? So, what I do is I literally just draw an arrow. Show that that's coming all the way down with me. And then I'm going to manipulate the left side. So, what are some things that I could maybe do over here with this side?
Cosecant is well, cosecant is 1 over sine. I don't know if that helps. Oh, well, and then...
And tangent is what?
Tangent is sine over cosine. So it does help.
Okay, so then now I can go through and I can cancel stuff. Sines cancel, cosines cancel, and what do you know?
Well, it's
1 equals 1. And I have verified it.
That's too easy.
I didn't say they were all going to be that easy.
Right.
That was just the first problem in that section.
False sense of security. I can't get security.
Alright, so then 28 is the sine of pi over 2 minus x times the tangent of x equals sine of x. Okay, so again, your first thing should always be, to keep you from trying to do something to the right, is to draw your arrow down, showing that it's just coming down and you're not changing that side. So what do I have that I can work with here?
Let me see. The sine times pi over 2 minus x, that equals cosine.
Okay, so this is cosine of x.
And then tangent would be sine over cosine.
Sine x over cosine x. So then cosines cancel, leaves you with sine of x equals sine of x. That was great. Okay, check mark symbolizes that you verified it correctly. All right, 30. And some of these are going to take a little bit more thinking than some of the others. So 2 minus cosine squared of theta is equal to 1 plus sine squared of theta. Okay, so draw your line down. I'm going to see if y'all have any ideas about something that I could do here. Or tell me something that looks similar to what we have on the left. It's not going to be something exact because we need to do something to it to make it do that.
I have 1 minus sine squared of theta equals cosine squared theta.
Okay? So we could potentially rewrite it that way. There's a way that's a little bit easier, but that is what we're looking for. Okay? So I'm going to show you what I think is slightly easier. Okay, would you agree with me that 2 is equal to 1 plus 1?
Yeah.
Yep.
Yeah.
So 1 plus 1 minus cosine squared of theta. Now, we've said before that cosine squared plus sine squared is equal to 1. Okay, so if I were to do 1 minus cosine squared of theta, what would that be equal to? Sine squared. So 1 plus sine squared of theta equals 1 plus sine squared of theta. Okay, because this part here converts to sine squared of theta. Okay, now David, the way you did it, that would have worked too. The thing that you said, you would have just had to do, because that was giving you a positive cosine value, you would have had to multiply everything by a negative, which is why I said that could be a little bit more complicated, but it would have worked for you as well. So sometimes there are multiple ways to do these, and that's fine. I'm trying to give y'all what I think is the easiest way to do them at the moment. So, all right, the next one is 32. And this one is the sine squared of minus x over the tangent squared of x is equal to cosine squared of x.
I never liked the word over. Implies something.
All right, so what is something I can do with this one?
I mean, I don't know if this makes a difference, but negative sine squared.
Okay, so taking the negative from inside and pulling it out front.
Yeah.
Okay, yep. So that's what that property says we can do. So then what's something else I can do here? Again, you're still thinking about stuff that you can rewrite a different way.
Tangent equals sine theta over cosine. I don't know.
Okay, so minus sine squared of x over, now because this was tangent squared, it's going to be sine squared x over cosine squared x. Okay, now keep in mind, this stuff is all on the bottom, okay, of this big fraction.
And then you can like multiply by the reciprocal.
Multiply by the reciprocal, so minus sine squared of x times cosine squared of x over sine squared of x. And then now, oh, hold on, let me back up briefly, because you're still going to have the issue with this negative, but if we rewrote this top part as that, because that's essentially what this is telling you to do, it's going to go away.
That makes sense.
The squared part is technically with the negative as well. So the other way that you could write this, okay, that we haven't really talked about, but this, sorry, it's going to be a little chaotic, but that is also equivalent to that, okay? So putting the squared on the sign or completely outside of it means the same thing. But what you have to remember is that that squared doesn't actually touch the x. So it doesn't become sine squared of x squared. Okay, it's sine squared of x. The whole thing is being squared, so the minus sign is going away. Okay, so really what I probably should do here is either rewrite it this way so that my negatives cancel, or rewrite it like this so that I see that my negative sign's going away with the squared part. Okay. Either way is fine. So then this down here, that sign is gone. Okay. Sorry, I had forgotten to mention that. So then now sine squared's canceled and leave you with cosine squared of x equals cosine squared of x. We have a winner.
Oh, that's weird.
All right, this next problem is what I would classify as a challenge problem. So, I'm going to have you guys try it.
It's gonna be bad.
Okay, on your own.
The challenge problem on the test apparently wasn't that bad.
This one's a whole page, pretty much.
Well, I'm dropping out. Bye. Yeah.
All right, 34 is the sine of x over 1 minus the cosine of negative x equals cosecant of x plus cotangent of x.
There's too much on that right side.
Don't touch the right side.
Correct. Do not touch the right side.
Say it.
Wait, so you're saying I need more space than this?
You probably can fit it there.
Okay.
Okay, so I want you to attempt this problem for a minute.
For a minute. Like exactly a minute.
No, like for a couple minutes.
Yeah.
We're going to see if you can do it.
We'll see.
The one hint that I will give you to get you started is that you might need a conjugate.
What's that again?
What's that?
Is that if you have like, all right, like let's say on the bottom when we had 2, well, I don't remember if we did that in this class. I think we did like 2 plus the square root of 3 on the bottom, and we can't have square roots on the bottom. So we had to multiply by 2 minus the square root of 3 over 2 minus the square root of 3. Same things apply with trig functions. So you may need to do something along that nature, but there's something you need to do before you can do that. No, you have to try or I'm going to send you out of the room and I'm not going to give you the answer. You have to try.
I think I see what's happening. I think I can get it.
Once you do that, it's not bad.
Yeah. I think I got it. Well, we'll see if I get it.
I'll give you about 2 minutes and see how far you get. give you about 1 more minute. I'll write the first step for you.
Wow.
I don't know how you got that.
Alright, and then there's your reciprocal step.
Okay.
Don't do anything to the top at the moment. Just leave the top alone and see if you can do something with the bottom. Try to solve the bottom part and then leave the top for the moment.
So what's on the bottom? Are you still looking for things that are similar that can act as substitutions, or you just
Foil.
foil?
So. Yes.
Give you a tiny bit longer since I gave you a couple hints along the way. See where we're at. It's a multi-day occurrence. Alright, let me go ahead and go over this. Alright, so leave the top alone. The bottom is a difference of squares, so that is 1 minus cosine squared of x on the bottom. Okay, so I now have sine of x times 1 plus cosine of x all over. How can I rewrite 1 minus cosine squared of x?
Sine squared of x.
Sine squared of x. So then now sine and sine squared, that's going to cancel, leaving me with 1 plus cosine of x over sine of x.
Oh, you can do.
Then because it has the denominator that's the same, I can rewrite this as 1 over sine of x plus cosine of x over sine of x, which then is the cosecant of x plus cotangent of x. And that's what I was trying to find.
I would not
Okay.
I better not do something on the test. There'll be like a bonus question on the test.
You never know.
Are you gonna change your lights since it's spring now?
I don't have any other ones.
Oh.
Well, I kind of do, but yeah, it's they're not LEDs, so I can't really use them.
Can you scroll down, please?
And just so you know, we are gonna have a quiz after this section. No, it's gonna be this week.
You wish.
Alright, so just a quick FYI before I give you your problems. What I'm going to do, I think I am going to make this quiz be Wednesday just because if not, it's got to be Friday and then we'd be moving on and I don't want y'all to get confused. So what I'm going to do is you'll get a blank sheet that looks like this. Okay? It'll be blank, obviously not filled in. And you will have the trig identities. Okay? You will need to write them down. Okay? And I will check them. Okay? If you don't put them, I will not give them to you. So if you decide, oh, I'm just not going to study them and she's going to give them to me, you will be very disappointed. That is not what I'm going to do. Okay? But let's say that you put sine squared plus cosine squared equals 1, and then you did, let's say you did 1 minus tangent squared is equal to secant squared. Okay, I'm going to fix it for you. Okay? I've even put on there how many of each there are so you know how many you should have when you come up to me. Okay, but I will do that. I know there's not a ton of time left today, so tomorrow will be time for you to finish this section because I think the other two sections y'all were pretty much good with overall, and so I don't really feel like we need to spend a lot of time reviewing that. We might do a quick little review, and then y'all would have time to work on the rest of these problems and ask questions if you have them. Okay, so the only problems, did I actually give y'all problems the other day at all?
No.
Okay, so then problems. All right, 11, 13, 15, 17, 19, 25, 27, 29, and 31. Okay, and I know that says more problems than usual, okay, and I know some of these take a little longer, but the more practice you have, the better off you will be, okay, because I've assigned almost every problem in the book between either you doing them or I've already done them for you. And on the quiz, I always pull from problems in the book. So by doing this, you will have done every single problem that is a possibility, okay, of showing up. So, there you go.